Okay, hello, Physics 30. So, just to go over a couple things. Now, I know that I kind of recognize that you guys felt it was going fast through the diagrams yesterday. So, what I'd like you to do is to practice making those ray diagrams yourself again, just those basic ones that we went through yesterday. As well, if you want a bit more guided review on how to do those, if you go to Doc Physics, this is his channel, Doc Physics. He explains how to do these ray diagrams. So, and I kind of did it in a similar style as he did. So you can go through and watch some of those. So you can just, like when you go to YouTube, find the channel, Doc Physics, and then I just went to videos, okay, for him. And then, so this is his channel. So if you go to his videos, you can search, and I just put in ray diagrams. So ray diagrams. And here you see there's the lens ones first, if you want to review those ones, and then concave and convex mirrors. So that, I think you should do that at home, you know. Make sure you really understand the basics of drawing the mirrors and the lenses ray diagrams, and then he gives a couple more examples too. Okay, then the next thing I want to do is I didn't get to answering, Hayden had a question about practice problem number 2 at the end of your lenses notes. So I'd like to go through that practice problem since I didn't take the time to do it the other day. So it says a concave lens has a focal length of 22 centimeters. So since it's a concave lens, we know that f needs to be negative 22 centimeters, and we're told that the magnification is 0.25. And then it says calculate the distance from the lens at which the image will be projected, so that's di. Okay, so we have our formula of 1 over f is equal to 1 over do plus 1 over di. This is what we're looking for. So since I don't have do, I'm going to have to substitute in something that I do know about it, and I do know magnification. So for my magnification, so for my do here, I can say my magnification is equal to negative di over do. So I'm going to rearrange it to solve for do so that I can insert that into that formula. So if I multiply across and then solve for do, I have do is equal to di divided by m. So now I can take this and substitute it in here. So now I'm going to rewrite this, just going to get rid of that arrow, as 1 over f is equal to 1 over, oh, and I'm actually going to just do it in this form. I'm going to go 1 divided by 1 over, negative di over m. So this right here. This should be negative di. Okay. Plus 1 over di. So now, since I have 1 divided by a fraction, I'm going to multiply by the reciprocal. So I have now 1 over f is equal to m over negative di plus 1 over di. Now I can just I'm going to factor out 1 over di. So now I have 1 over f is equal to 1 over di. Oh, and I'm going to actually put the negative on the top of this fraction, so then I can just factor out 1 over di. So then I have 1 over di multiplied by negative m plus 1. So now that I've done that, I'm going to rearrange to solve for my di because that's my unknown. So since this is multiplied by everything in this bracket, so I'm going to divide. So I have 1 over f now divided by negative m plus 1 is equal to 1 over d. Now, you could simplify this a lot too before putting in numbers, but at this point I just put in my values and, you know, just kind of move forward from there. So now I have 1 over negative 22 centimeters divided by negative 0.25 plus 1. Because remember, this was the one that I manually made negative, since I know that its focal length is negative. So that's the only value, the only variable that you know, like you manually put it in yourself, is the f, is equal to 1 over di. So when you put that into your calculator, you get negative 0.0606 centimeters. Well, it's centimeters, negative 1, is equal to 1 over di. So then di is equal to 1 divided by negative 0.0606 centimeters. So then your di, once you put that in your calculator, you get negative 16.5 centimeters, which is the answer. Hooray! And we also know that it is virtual, since it's a concave lens, and and that's our answer. Hooray! So, so that's for your lenses stuff. So next we will finish the mirrors lesson. So go on to the next video for the mirrors lesson.